Hello and welcome, student. Before we start solving previous tests and exams, I would like to make this important disclaimer. The following will be just a practice exam, and it's only intended for revision purposes only. So it has nothing to do with your actual exam. It is not a model for your exam. It's just for you to revise, to test yourself, to practice more, keep yourself with a timer, be in the exam environment. You shouldn't assume the actual exam will be identical to this one. It's also crucial before you start viewing this review is that you complete all the homework problems, look at the lecture notes, and watch the previous video to ensure a thorough preparation for the exam. This is only a practice exam. It's just for revision. It will not help you understand the material. You need to do the homework, lecture notes, watch the videos before you come and see this exam. Welcome to this previous exam for Calculus 2 and this exam from the academic year 2022-2023. As you can see in this exam, it consists of a couple of multiple choice questions. We have 11 of them, as well as the written questions. So usually the best way to do those exams is we will start with the written questions because they need us to think and write, and then we will go to the multiple choice question. In this revision, I will try to be as slow as I can, as detailed as I can. Of course, in the final, you can even move faster, but I will just explain it. It's like the first time you see it, so I will just go through all the details to remind you of the whole story so that you get prepared and at least you remember some of the important parts here. If we go to the first question here, it says find the area, so I need to find the area of the region bounded by the parabola and the line. Now, if you remember how we solved the area question was we start first by sketching the region. So first step, sketch the region. Now, how do we sketch the region? Of course, we have this here. We have this here. Let me just do it to the left side so I can do the intersection point to the right. First of all, I have the parabola, which is y equal x squared. That's the easy one, which looks like this one here. This is just a rough estimate. This is the parabola. And then you have the line y equal to 2. Remember, if we have y equal to a number, this will be a horizontal line at that number. So the area will be like this. And now the area we are talking about is this one here. Next step, of course, directly we need to find the intersection point. Where do I find the intersection point? Let me do it to the right. So intersection points are. Now, if you remember, the intersection point is when the y of the green of the orange one is the same as the y of the red one. Because both of them are in terms of x, we get y, the orange, equal the y with the red. Now, the y with the red is just the equation x squared. The y in orange is 4. We need to solve this equation. So we take 4 to the other side, make it 0. Now you can use your calculator or you can factor, mod 5 to 3. You will get two answers, -2 here and 2. So we got the intersection points. We will see why do we need the intersection point, because next is we need to find the area. So what is the area? The area is the integral of, how do we find the area? Remember, we need to put a rectangle in the middle of the region and check what is this rectangle looks like. This is the rectangle. Just put it in the middle of the region. Or sometimes you can think that there is somebody standing here. Look, what is the top of that rectangle? What is the bottom? And we subtract them. So here we will have the top minus the bottom. Of course, the top function is the orange one, the bottom function is the red one, and of course we need to do everything in terms of x, so we end up with dx. Now, if you move this rectangle maximum to the right, you will end up at 2. If you move this rectangle maximum to the left, you get smaller and smaller, and it will end up at -2. So this integral will be from -2 to 2. Now things are getting a little bit easier because I know what is the top function. The top function was only 4 minus the bottom function was only x squared, and then we have dx. We do this integral, and then we substitute 2 and -2. Now the question is, what is the integral of 4? It's just 4x. What is the integral of x squared? It is x power 3 over 3. So this will be just 4x negative x3 over 3. The next step, with your calculator, substitute 2. Everything you see here, and instead of x, write 2 in your calculator. That will give you 16 over 3. Next, do the same. Everything, just put -2. It will be -16 over 3. Okay. Finally, just write in the calculator 16 over 3, -16 over 3. That means 16 will be just multiply, so we get 32 over 3. And that's the answer for the first question. And that's we find the area. Of course, whatever we change here is the same concept. If the question was like find the volume, we must give you the axis of revolution, and then you apply the formula for the volume. But the structure of the question is the same. Moving to question number 2. Question number 2, it says evaluate by partial fractions. So we have to use partial fraction, and we need to evaluate. What do we need to evaluate? We need to evaluate this definite integral. So the first step in this solution is to write the partial fraction. So you have x plus 4 divided by x squared minus 5x plus 6. You need to write it as x plus 4 in the top, and down you need to factor it if you can. Sometimes you can, sometimes you cannot. So if we do it with the calculator, since we start with x squared, you need to start here with x and x, minus and minus, and now you can use your any method you want. One of the method that you can use is mod 5 3 in your calculator. You will find two numbers, and those two numbers are 2 and 3. Next, we need to write the partial fraction. What does it mean, partial fraction? It means we split the fraction. So it will be x minus 2, x minus 3, and then we have two numbers. Those two numbers are a and b. That's what we get. Next step, you need to multiply everything here by this. So let me just copy this. You need to multiply it by x minus 3, x minus 2. You do the same for every other one. So here we have a over x minus 2 we need to multiply it by x minus 3, x minus 2, plus b divided by x minus 3, x minus 3, x minus 2. So we multiply everything by the factoring that we get, or if you think about it, by everything you see in the denominator. The reason why, we want to clear the denominator. Anything of the denominator, we want to clear it. How do we clear it? We multiply by everything we see in the denominator. Now we just use the red pen to cancel. So this cancel, this cancel, this cancel, this cancel. So on the left side, we will end up with only x plus 4. On the right side, we get x minus 3 will survive, and x minus 2 will survive. And here we have a and b. And that's the equation we would like to work with. Let me just call it star. What do you mean I would like to work with equation star? I need to find a and b, and there are many, many methods to find a and b. The easier method is we need to plug in values for x. Choose for me a wise value for x that I can use. One of the values for x, as we said before, it will be those two numbers that we get from the calculator, which are this and this. The reason why, if you plug in 3, you will get 0 here. So everything will just disappear, and that will just give you an equation with the b. Now, if you plug in 3, the left side will be just 7. The right side will be a times 0. I don't need to write it actually, but I just want to show you. Plus b. Now, if you plug in a 3, this is just 1. That means b equal to 7. We find b. That's the good news. It's very good news that we find b. Next, we find a. How do we find a? We substitute x with another number, which is, as we said before, it's 2. Now I'll do it quickly. If you substitute here 2, this would be 6 to the left, equal. If we substitute 2 minus 3, this is -1. If I substitute 2 here, this will just go away. I don't need even to write it down. And that will give me the value for the a, which is -6. So far, good news. I find a, I find b. Now I can do the integration. I'll go to the next page and I finish the question. So where were we? What we did, we take this long integral, long fraction, and we write it as x -3 plus x -2. What are the numbers on the top? It was -6 and 7. Now, if we do the integration for both sides, the left side is the one I need to find. No one give me this one. It will be the integral of x minus 3 dx plus integral of x minus 2 dx. 7, -6. Now, this integral, we know it. It's just the len. So it will be just -6 len absolute value x minus 3 plus 7 len x minus 2. Of course, plus the constant of integration, and that's the answer here. So partial fraction, find a, b, and then do the integration using the formula that we have, and that's question number 2. Let me go to question number 3. And as I always advise you to do when you watch this video, is pause now, try to solve this question by yourself, and then play and check. That will also give you more kind of a confidence that you know what to do and how you do it, and also you will have another way to verify your solution. So imagine this exam is like a mock exam for you. Make a timer, try to solve it yourself, and then play this video, check the answer, find where you get it correct. You will get more confident. Where you did it not, then you have to practice again. And this question is giving to me that use ratio test. So I have to use the ratio test, no other choice. I will use the ratio test for this one and check if it's convergent or divergent. Now, let me remind you what is the ratio test. Ratio test, we need to find a limit, we call it L, as n goes to infinity, of the absolute value of an plus 1 divided an, which will give me the following. First of all, you write the same an down here. In the top, you need to write the same one, but instead of each n, you need to write n plus 1. So this n, I will write it n plus 1. This n, I will write it n plus 1. I'm doing here slowly so that you can see what is the difference. So just change n to n plus 1. And that's all what you need to do in this question here. Now, if you put n plus 1 for both, get n plus 1 in the top and n plus 1 in the bottom. Now, if we do that, we will get n plus 1, that will give me n plus 2, and in the power of the 5 in the top, it will be negative n. If you distribute the minus, you will get it as plus 1. So just let me finish that. As I said here n plus 1, n plus 1. Now, if we distribute the minus, it will be negative n, negative 1. So this would get us to the following. So here is limit n goes to infinity, 5 negative n, n plus 1. In the top, we have 5 negative n negative 1 divided by n plus 2. Okay, we have a stack of 4. 1, 2, 3, 4. How we do it? We take the first and the fourth together. So that will be just n plus 1 here with the first one, 5 negative n negative 1. And then you do the 2 and 3. Remember, I need to write them down next to each other so that we don't do any mistake in the calculation. Let's see now this limit. Well, there is some kind of cancellation. 5 negative n, 5 negative n, so we will just have 5 to the power of negative 1. So this will remain. And then we have n plus 1 divided by n plus 2. Which, if we simplify it, 5 negative 1 will get out. And then we will get this usual limit where we have n plus 1, n plus 2. Now, if we do direct substitution, you get infinity over infinity. So what we need to do? Of course, we need to do L'Hopital here. So if I do L'Hopital, I need to find the derivative of the top, which is 1, derivative of the bottom 1. 1 divided by 1, this answer is 5 negative 1, which is definitely 1 over 5, and then you have to compare it with 1. This is less than 1, so the series converges by the ratio test. Why the ratio test? Because the limit is less than 1. And that's how we solve this question. Of course, there is another part of the question, if you can focus with me here. It says, what are the other tests you can use to decide the convergence? Well, ratio test is one of them. We did it. Now, there is another one for the ratio test called root test. Of course, you can use the root test. That's perfectly fine. Comparison test, maybe, yeah. Comparison test with Bn equal 5 negative n, and then you do the limit comparison test. Integral test will be doable, but will be difficult. So yeah, those are the tests that you can use. Of course, in this question, we stick with the ratio test. Now, what happened in the exam if we didn't say the ratio test? Of course, because this is exponential function, something to the power of n, ratio test and root test are the one that will come close to your mind as a first option. Now we go to question number 4. Let's see question number 4 and how we can do it. Question number 4, write the power series representation for this function. Well, before I do that, I need to remind myself of one of the Maclaurin series for the famous function, and that was 1 over x. If we write it as sigma notation, it will be xn. If we write it as expanded form, it will be in that way. Now, my question is not 1 minus, it is 1 plus x. So the first one is we need to adjust it. So how do we adjust it? We just write minus x. So it will be minus minus. Now, use this formula here, and instead of each x, write minus x. So this would be equal to the same formula if I do it closed form to the n. Or if I do it as expanded form, and instead of x, I will just make an empty bracket. Later, I will fill it out. What do I fill this empty bracket? I fill it with negative x, negative x, negative x, negative x. Now, let me go to the closed form and do something about it. So it will be negative 1 to the n. Everyone will take its own share of this n. And in the expanded form, it will be 1 minus x plus x squared minus x cubed plus x power 4 and so on, so on, so on. And that's the first part of the question. We write the power representation for 1 divided by 1 plus x. Next, it's asked me differentiate the power series for this one term by term to find the sum. So we need to take this one and we find the derivative. Since he's only using the closed form, I will just take derivative of this and derivative of this. And let's see what will happen. How do we find the derivative of this one? Well, there are so many different methods. One of them is you can just write it as power negative 1. Now, the derivative will be negative 1 to the negative 2, and here you write 1 plus x, which is the same as negative 1 over 1 plus x squared. That's the derivative of the left side. Now, what is the derivative of this one? Just the n will go down and we will do it minus 1. So it would be just n from 0 to infinity, negative 1, n x n minus 1. Of course, if we substitute n equal to 0, this will get cancelled. So we safely can start from 1 to infinity. So the final answer is this series, which is given to me in the question, is the same as this one here. And that's question number 4. And that's the end of the written part in this exam. So there's a couple of questions as written part. As usual, please start with the written part because it needs you write the complete solution. And then you can go to the multiple choice part. Some of them will be quick. Some of them will take time to be solved. So what I will do, I'll solve them one by one. We'll focus with the questions, try to solve them, and we'll see if there is anything else we can just later solve it here. Let's go to the first question. It says compute the following limit using L'Hopital rule. So I have to use L'Hopital rule, and the first step we do direct substitution. Now if we do direct substitution, in the top you will get e power 0 minus 1. In the bottom, you will get sine 0, which is, if you do it with your calculator, it will be 0 over 0. So yes, we need to use L'Hopital rule. How is L'Hopital rule? We take the derivative of the numerator, derivative of the denominator, and then we find the limits. What is the derivative of the numerator? The e power 2t, it will be the same, e power 2t, and then you take the derivative of whatever inside, which is just 2. Derivative of 1 is 0, so it will go away. Derivative of sine is cosine. Now, if you have the calculator, substitute, you get just 2, which is the first answer here. Question number 2, it says that the substitution u equal tan 3x transform this whole integral to something easier. So the good news, I have du. So I just need to find dx. Derivative of tan is secant squared 3x. And because there is a 3 here, the derivative will also have 3. Because we take the derivative of the inside, dx. That means dx equal du over 3 secant squared 3x. Now, take those information, substitute them here. So if I just do it directly, what I'll get is tan 3x, it will be just u squared down there, plus 4u plus 4. Now we have 12 secant squared 3x. Now the dx is just du over 3 secant squared 3x. Now there is cancellation. Even the 3 and 12 give me only 4. So the final answer will be 4 in the top. This is 4 and this is u. Now which answer is similar to this one? There is only one answer that starts with 4, which is C. Question number 3, find the volume obtained from the following specification. We have to sketch, find the intersection point, and then we will see which method of volume we need to use. So if we sketch, that would be an easy sketch. Well, first of all, y equal x plus 1, it will be, if x is 0, it will start with 1. So it will look like this. Just a line in that area. Y equal to 0 and x equal to 0, those are the x-axis and the y-axis. How do I know? Because y equal to 0, this is horizontal line at 0. And then we have x equal to 2, which let me do it with purple. X equal to 2, it's a vertical line here. And now where is my region? Where is the region between all those? I guess this is my region. Of course, don't miss it with this one, because it will be the region between all these. And then we need to do it around the x-axis. This is the x-axis. Okay. Of course, this is unnecessarily given to me because now I would get confused whether to use this region or this region. So I just need to change. Keep it as this. We'll find the answer and see if we get one of these answers up here. But I do believe that y equal to 0 shouldn't be there. So if we assume that, we need to find the intersection point. And for that, it will be just the y in red should be equal the y in green, in orange. Which is x plus 1 equal the y in orange is just 0. That means x is negative 1. So we'll start from negative 1. I'll assume this is the whole is my region. Now the axis of revolution is horizontal. The functions are given in terms of x. So which method we will use? We will use the shell method, which has r out and rn. Of course, there is no rn because there is no space between the region and my axis up here. So let me go to the next page and let me write the formula for the volume. So the volume will be just pi integral from -1 to 2. You need to write r out minus rn. What is R out? As we said, it is, we take an arrow from the axis of revolution to the minimum we can get in the region. How long is this arrow? It will be top minus bottom. So it will be just the red one, x plus 1. Now, of course, this one will be, if we do it quite correctly, it will be 0 minus 0, because nothing top, nothing bottom, so there is no Rn. So we just get this integral here, this 1 to 2, which if we expand it, it will be 2x plus 1 dx equal by, if we do the integration, it will be x3 over 3 plus x squared plus x, and we substitute from -1 to 2. And we find the answer using the calculator. The answer is 9 pi, which is this one. Next, find the indefinite integral sine cube. And he's already giving me the formula to do the sine cube. He say if you want to find the sine cube, just substitute n equal to 3. So if we substitute n equal to 3, it will be -1 over 3 sine n minus 1, so it will be sine cosine x, plus integral from, if we substitute n equal to 3, it will be just 2 over 3 integral of sine x dx. So the final answer will be -1 over 3 sine square x cosine x. Now what's the integral of sine? You will think it is cosine, but it is not. It is minus cosine. Now look at those answers. We'll start with negative, negative. The only answer that is close to us is, which one? I think it's the first one. Finally, we need to find this improper integral. So how we will do it? We just need to go away from the infinity. And then we use the limits. So keep the limit. Do the integral. How do you do the integral of x ex squared? Of course, we can use u substitution, because the derivative of -x squared, it's already here. So if we use u substitution, this will be e -x squared -half. Why? Because when you do the derivative of this one, it is -2x, and you only have x, so you divide by -half. And then you substitute it 1 by 0, 1 by 1. Next, just find the limit as b goes to infinity. How do we find this one? Just -half e b squared plus, if we substitute 0, it will be just half. Now, this can be written as limit b goes to infinity e b squared. This can be written as -half 2eb squared plus half. If we substitute infinity, it will be 1 over infinity 0, so the only remaining part is 1 over 2. And that's question number 5. For question number 6, this sequence is given by S. It's a sequence. Whether it's divergence or convergence, we need to find the limit of an. So what's an? It is n over n plus 1. Now you can use L'Hopital. And for L'Hopital, this is just 1 over 1, and the answer is 1. So that's what we get here. Now, if the answer is a real number, we say that the sequence convergent. It's a sequence, not a series. So, I don't know, where's the answer? The answer A is divergent, decreasing, increasing, constant, unbounded, none of the above. Okay, convergence is not there. We need to check if it's increasing or decreasing. This sequence, if we write it down, it will be clearly decreasing. Next, of course, somebody can also claim this is none of the above because he thinks that this is convergent. So this example is not a good one for multiple choice because could be confused that if it's none of the above because it's convergence, but also it is decreasing. So we have to be careful with this one here. Oh, geometric series, we like geometric series. And remember, if we want to do geometric series, the first thing to do is we need to see it start with 1. So how do you start with 1? Take 2 as common factor. So the first one will be 1. Second one will be the R. And next will be the R square. And next, and so on, so on, so up to 3. Now we apply the formula for the geometric series. We write 1 over 3 here. The best way, write this as a whole in your calculator so that you don't do any mistake, unnecessarily mistakes. And the answer will be just 3, which is next question, consider the alternating series. Use the appropriate test to study convergence of the given series. Well. We need to check, is it absolutely convergent or conditionally convergent? Or it's divergence. How do we check? The first step, we have to do it in 2 parts. We do the alternating part, and we do the absolute part. Remember, we said we will always do the absolute part first, because if the absolute convergence, everything is convergence, we have a shortcut to say it's absolutely convergence. Now, what is the absolute part? We look at the series. Which is square root of n over n plus 4. How do I check if this is convergence or divergence? I will do the comparison test. With what I'm going to comparison this with, we take the highest power over the highest power, which will end up with 1 over n, which is 1 over n power half, and we know this is divergence. However, this is not enough. We need to use the comparison test. And I will use the limit one, so I don't need to check which one is greater than which one. So I will use the comparison test. What is the comparison test? We take the limit of an in the top, pn in the bottom, which will be the limit. What is an? It is square root of n plus 4. What is pn? It is 1 over square root of n. Stack of 4, how do you rewrite it down? You take the first and the fourth, so you will get n in the top, n in the bottom. Now, if we use L'Hopital, the answer will be just 1. If the answer is 1, which means between 0 and infinity, it means both series are the same. So the final conclusion that this one is divergence, which means this is wrong. It cannot be absolutely convergence. Now we go to the alternating part where we need to check 2 things. First, we need to check an decreasing. Second, we need to find the limit of Pn, the absolute part. Now, if we find the limit, we use again L'Hopital, will be 1 over 2 square root of n over 1. The answer is 0, so we are fine. And then you need to check if it is decreasing, which it will be decreasing, so this will be just converges. So it will be conditionally converges because the absolute part is diverges, the alternating part is converges. Next question, we need to find the root test for this one. So just take this one to the next page and then we'll do it. Now the root test is we take L as the limit, n goes to infinity, and then we take the nth root of an, which was, I think, n over 2n. Let me just copy it back, 3 plus 2. And that's easy going here. What will happen? We have the nth root and the power of n. What gonna happen here? Well, of course, they will cancel each other, so you will end up with no powers. And now you can just go ahead and use L'Hopital. So you get 1 over 2, which is half. Of course, half is less than 1, so this is convergent. And it will be, of course, absolutely convergent because it is the absolute value, which is the convergence. It's a positive one, so it's absolutely convergent. The interval of convergence of the power series. This is a very important question, and I think we need to spend some time dealing with this one here. So I'll just have a new page where I solve this question. So that's the question here. It was x minus 5 power n over n squared. It's written in terms of k, but I'll just do it in terms of n because we are used to in terms of n. Solution. Now, how we are going to do this example. It's very easy and very simple, straightforward. What we need to do is we need to find the interval of convergence. So we need to find the limit as n goes to infinity, absolute value for an, and in the top, you write for me everything but n plus 1. So the same series, you write it in the bottom because I'm using the ratio test. So I'm using x minus 5 to the power of n divided by n squared. Now the same thing, you write it in the top, but instead of n, you write n plus 1. So you get n plus 1 squared. And now it's the good news. We have a stack of 4. How do we deal with stack of 4? Stack of 4, it means x minus 5, n plus 1, x minus 5 to the power of n. Now, what we have next is n squared. And here we have n plus 1 squared. Of course, if we have the cancellation, x minus 5 power n, x minus 5 power n, what we will get is only one thing. Just n squared, n plus 1 squared. And then we have x minus 5 in the top. Now, if we take x minus 5 outside, we need to take it with what? With the absolute value, because we don't know the x. Now, what is remaining is always positive, so I don't need the absolute value for the n because n is already positive. Now, we need to find this limit. How I'm gonna use and find this limit? Let me just do it here in a different color so that we can see it. You need to find this limit. And now let me do it with the obvious way of just using L'Hopital. Now, if you use L'Hopital, you need to find the derivative of the top, which is 2n. How do you find the derivative of the bottom? The 2 will go down. We subtracted 1. Now you write n plus 1, and then you take the derivative of the inside, which is 1. If we do that, there will be cancellation. The 2 and the 2, so we get just n plus 1. Now, again, use L'Hopital. You will just end up with this one here. So the answer would be just 1. So finally, the final answer will be x minus 5. What shall we do with x minus 5? We go to the next page. And we say by the ratio test. We have the convergence will happen if the answer is less than 1. Which means x minus 5 will be between 1 and negative 1. Which means x itself between 6 and negative 4. Sorry. So if we do the number line now, we know where the x will converge. We have 5, we have 6, we have we have 4. So it will be convergent in this area here. Between them, it's definitely convergent. So here is convergence. How about here? After you remove from 6, this is diverges. If you go less than 4, this for sure diverges. Still, we don't know. At 4, we don't know. At 6, we need to check the endpoints. How we are going to check the endpoints? We will go and substitute x equal to 6 and we see what we get. Let me have a new page. So at x equal to 6, what will happen? Remember, my question was x minus 5 power n over n squared. Now, if you substitute 6, it will be this one, which is summation of 1 over n squared. And this is converges by the p-test with p equal to 2 greater than 1. So in one endpoint, it's converges. Let me go back and write the answer here is that this is converges. The next one is what happened exactly at 4. So at x equal to 4, the series will be x minus 5 power n over n squared, and this will be exactly, if we substitute 4, negative 1 to the n over n squared. Of course, here we have two solutions. Either we use the shortcut by only checking the absolute part, which is converges, so the alternating part will be converges, or, and that's even smarter, to use the alternating series test, which means you will check two things, you can check them, this will be converges. So the answer here, if we go back, that this also would be converges. Now we have two converges in both sides. And this is the only answer that has convergence on both sides. Final question is the value of telescoping series. So I need to take this series, write it as telescoping series, and then find the Sn. Let's do it. It was what? n plus 1 starting from 1. Solution. How we are going to do this one? Well, first of all, you need to write the partial fraction. We just did partial fraction at the beginning of this video, so I'll do it quickly here. You get n, and you separate it from n plus 1. And here you have a, and then here you have b. How do we find a and b? We multiply everything by everything in the denominator, and if we do that, I will just be quick here. In the left side, we will get 1. In the right side, we will get a with the other factor, which is n plus 1, plus b with the other factor, which is n. Next step, substitute value for n. I will substitute 0. If you do that, a will be just 1. Next value, substitute -1. If you substitute -1, the b will be now multiplied by -1, which means the b is equal -1. Why this is important? Because an now will be just a over n, which is 1, minus b over n plus 1. That's the an. But I don't want an, I want Sn. In order to find Sn, we need to find S1, S2, S3, and then we find what is the pattern to find Sn. So let me just go to the next page. Write an here. And now we need to find S1, which is the same as A1, which is 1 over 1 minus 1 over 2. Nothing give me any information. However, S2 is A1 plus A2. What is A1? It is 1 minus half plus, now if we substitute 2, we get half minus 3 over 2. Now you can see the cancellation. Everything in the middle will cancel. The only one will survive the first one and the last one. Let me confirm it with S3. Is that correct? If I do X3, can I see the same pattern? So 1 minus half, half minus 1 over 3. Now, if we do 3, it will be minus 1 over 4. Is it the same pattern? Half cancelled, third cancelled. So the only one that survived is the first one and the last one. So what do you think Sn will be? Well, we have to write Sn here. It will be A1 plus A2 plus A3 plus plus An minus 1 plus An. I don't have a space here. I'll go to the next page and I will write it down. This is A1. This is A2. Here you have to write for me An minus 1. And here you have to write for me An. A1 was 1 over half, half minus 1 over 3. An was 1 over n plus 1. Now what is the one before that? It will be the same as this one, except you remove this n and you write it n minus 1. This is n minus 2. So this will be just 1 over n. Why 1 over n? Because this, if you remove this and you write n minus 1, get cancelled. So you get only 1 over n. Now, see the pattern. Do we cancel everything? Yes, cancel everything. So the only one that survived is what? N plus 1. So finally, what is the sum? The sum is the limit as n goes to infinity of Sn. So it will be just the limit as n goes to infinity of 1 minus 1 over n plus 1, and that's equal to 1. So finally, after all this, we find the final answer to be 1, which is part D. And that's it. That's the practice exam. However, there is a big issue in this exam that it doesn't have any question on the Taylor or Maclaurin series, which is strange. And for that reason, I will now solve more question about Taylor and Maclaurin series, because I cannot see any Calculus 2 exam that doesn't have a big portion of Taylor, Maclaurin series, estimation of error, and all those concepts. It has a heavy part of any Calculus 2 course. So that will be the next part of this video, is to go through some Taylor and Maclaurin series just for you to practice. It's not included in. Okay, welcome back, students, to the Maclaurin series and Taylor series. In this question, as you can see that the center is a equal to 2. Now, if a equal to 2, this is what we call it the Taylor series. If you haven't watched part 1, please go back and watch it, because it will really help us here. Now, what we need to do, Taylor series, we need to write f of x equal c0 plus x minus 2, because 2 is the center, c1, c2, x minus 2 square, c3, x minus 3 cube, c4, x minus 2, 4, and so on. And as we did last time, in order to find what is Cn, we need to find the derivative of the function, and we substitute it at 2, because 2 is my center, and we divide it by n factorial. So what we'll do now is we'll make a table, little one here. And here is the derivative. And here is the derivative at 2 exactly. And here will be the Cn, which means the derivative at 2, and we divide it by how much in factorial. So we will do the first maybe 5 terms, and we see the pattern as much as we can. Now, what is my 0th derivative? It is the function itself. So the first derivative is 5x4, 9x squared plus 1. Next derivative, 20x3, 18x. Next derivative, 60x squared with 18. Next derivative is 120x. I think I need to take the fifth derivative. It is 120. And then it will be just 0. So I can see the pattern is that this will not be an infinite series. It will stop at certain number. Now, if we substitute the 2 up here, what we will get is 2 to the power of 5. And then 2 to the power of 3 plus 2. This will give me 58. The next one will be 5 times 2 to the power of 4 plus 9 times 2 to the power of 2 plus 1. And that's 117. Next one will be 20 times 8 plus 18 times 2. And that's 196. And then we will be 60 times 4 plus 18, 258. And then we have 120 times 2, 240, 120, and then 0. Now for each one of these we have to divide by the n factorial. So this will be 58, this will be 117. Now 196 divided by 2 factorial, this is 98. Now 258 divided by 3 factorial, this is 43. Now 240 divided by 4 factorial, this is 10, this is 1, and those are zeros. So I think everything is straightforward now, and the Taylor series for this one will be 58 plus 117 x minus 2 plus 98 x minus 2 square plus 43 x minus 2 power 3 plus 10 x minus 2 power 4 plus x minus 2 power 5. And that's it. So you don't need to have a series. Sometimes the Taylor series is not a series, but again, this is what we get. Now, you might get confused that how can I write polynomial in a different format? That would be fine because here we change the center. Okay, so just follow the steps. Everything should follow up the same way. If we have another questions, maybe similar to what we did, this one with the cosine, maybe we can try it. So here a little bit, I will go quick with this one. So it is f of x, which is cosine x. It will be c0 plus c1 x minus pi over 2 plus c2 x minus pi over 2 square, c3 x minus pi over 2, 3, and so on. Again, we need to make our table up here. Zero, 1, 2, 3, 4, 5, 6. And then the nth derivative. So we start with cosine x. Next derivative is minus sine x. Next derivative is negative cosine x. Next derivative is sine x. And then I will get back to cosine x. Let me do it in a different color so that you can see what's going on here. Now you can see that I will repeat what I did before, because look, once you end up in cosine again, whatever come next will just repeat itself. So it will just be minus sine x, minus cosine x, sine x, and then I will get back into cosine x. Let me go back to the white color. And so on. So the pattern is easy, we can see it because at every 4 steps we go back to what we started with. So let's focus on the first part, and I think the rest will follow. The next one is we have to substitute pi over 2. So this would be 0, negative 1, 0, 1. And as you can see, this has to repeat itself. So it will be 0, negative 1, 0, 1. And so on. As you can see clearly here that the odd will survive, the even will be vanished. Keep in mind, the odd, they are surviving, and they are also alternating. Keep in mind, it's negative, positive, negative, positive. So we have alternate. That's the first remark I can see. And it's only odd. Keep this in mind. It will be useful in a minute. Finally, we need to find Cn. Cn is the nth derivative at pi over 2 over n factorial. This is 0. This is 0, 0, 0. Now, those are what? It will be negative 1, 1 over 3 factorial, negative 1 over 5 factorial. This one will be 1 over 7 factorial. Can you guess what would be the next one? Exactly, it will be 0, and after 0 will be negative 1 over 9 factorial. Why this is negative? Because it's alternating series here. So finally, we write the final answer. Cosine x can be written as negative x minus pi over 2 plus 1 over 3 factorial x minus pi over 2 power 3, only the odd, and it's alternate. So if we just put everything together, what we have is alternate. This is for the alternate. We have odd factorial, and we remember we said odd is 2n plus 1. And then we have x minus pi over 2 to the power of odd. Okay. I think that's what we want to say up here, and that's the idea. Now what we will do in the next video, part 3, we will write the formula that you need to know for the famous functions. We already have seen the Maclaurin series for 1 over 1 minus x, tan inverse of x, ln 1 plus x. Go back to section 11.9 and you will see that we already have them. Today we want to write 3 formulas for the 3 famous function ex, sine x, cosine x, and that will be in the... Hello students, back to part 3 of section 11.10. Today we will discuss the Maclaurin series for 6 famous functions, which are ex, sine x, cosine x, tan inverse, the ln, and 1 over 1 minus x. Now, in each one of these, we can do exactly what we did before, making a table. Okay, and then we find the derivative. And then we substitute the derivative at 0, and you are wondering why 0, because it is Maclaurin series, so we substitute at 0. And then we find Cn, which is the derivative at 0 over n factorial, and that will be the coefficient in the power series. Now, luckily for those 6 functions, the formula, we can do this table and we can find the formula. But what we really need now is not finding the formula. You can read it in the book. But we need to write them down because we will use them heavily in the coming few lessons. So, we start with 1 over 1 minus x. I think this is familiar. We already did it. This is the geometric series. And as expanded form, it's 1 plus x squared plus x cubed. And as a closed form or sigma notation, this is from 0 to infinity, x to the n. Of course, the radius of convergence is from negative 1 to 1. This is the interval, and the radius is 1. Keep in mind, this is converges only if x between negative 1 and 1. So this is number 1. Number 2, of course, tan inverse and ln x, we already did them. I will not write them down here. We can go back and see them. Ex. And here I want you to memorize it with me. It will be exactly the same as this one, except we have something in the denominator. So it will not be x to the n only, it will be x to the n over n factorial. That's the ex. So almost, if you know what is 1 over 1 minus x, a quick twist, you can find e to the power of x, and as I said, it's exactly the same, except x over n factorial. So it will be 1 plus x squared over 2 factorial plus x3 over 3 factorial, x4 over 4 factorial, and so on. Here, it is also over 1 factorial, but 1 factorial is already equal to 1. Here, 0 factorial and 0 factorial already equal to 1, so we don't need to write them down. But they are there, but we don't need to write them down. 3 is sine and cosine, and let me use the white color here. Now, sine and cosine, again, if you want a quick way to remember them, they will take everything from ex. But sine will take the odd power, cosine will just take the even power. So sine will take only the odd power, so it will take x cubed over 3 factorial, x5 over 5 factorial, and so on. That's the sine. So it will be x cubed over 3 factorial, x5 over 5 factorial, and so on. Now, there is a twist in the sign. It is alternating. So it is almost the same as ex, but it will be alternating. So this would be negative, this would be plus, the next one would be negative. So if we try to write it as a closed form, remember we are taking the odd power, so it will be 2n plus 1. And the factorial is exactly the same as the number in the power, so it will be over 2n plus 1 factorial. And then it's alternating, so it's negative 1 to the n. That's the sign. Now for the cosine, we said we take the even power. And again, it will be alternating, by the way. So it is minus, and then x4, 4 factorial, and then x6, 6 factorial, and so on. Which is, if we write it as sigma notation, this is the even powers over even factorials, and it's alternating, so it is minus 1 to the n. Now, please find a way to memorize all those 4 formulas. They are very much important for us. They are very, very important for us. The tan, I can't even write the tan. Let me do it in a different color. The tan inverse of x. It's exactly like the sine, but without the factorial. So it would be x minus x cubed over 3 plus x5 over 5. And I guess this one will be x7 over 7, and so on. Which is just take the alternating, take the odd power, and off we go. Now for the radius of convergence, all of these are from negative infinity to infinity. So they are converges everywhere. We don't need to care too much about them. Except, I think, number 6, which is the len. And the len will be just integration of this one, but with alternating. So it would be x squared over 2, and so on. So number 6, go back and see them, 1 plus x. They are x minus x squared over 2 plus x3 over 3 minus x4 over 4, and so on. Which is alternating, so this is negative 1 to the n, and then x to the n over n, and here n start from 1 to infinity. Just I write n plus 1 to fix that the first term should be positive. So please keep this in mind. We will need them whenever we use them, and let's go and see how we will use them in several examples. Oh, the first one, he wants me to find arctan of x squared. That's easy, because what is arctan? Arctan is the same as tan inverse, by the way. So it is tan inverse. Now for tan inverse, I know exactly what is the formula. Remember, the formula for tan inverse, it is exactly, if I just write it as expanded form, start with something and then alternating. So something and then something power 3 over 3 plus something power 5 over 5 minus something power 7 over 7, of course start something, and so on. Which if you do it as expanded form, it is alternating and then something to the odd power over the odd power. Now what is the something? It's only the input. If it's x, I write x, 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 x. Now we have x squared, so this is x squared, and x squared. So just let me write x squared, x squared, x squared, x squared, and x squared. Now this one you can expand it very easily and you get the final answer, which is x squared minus x6 over 3 plus x10 over 5 minus x14 over 7, and so on. And if you do it as sigma notation, it will be alternating, and then it will be 4n plus 2 over 2n plus 1. And that's exactly what you need to write for the Maclaurin series. Now remember, this one you can do it with the table, but it will be lots of work because you need to see the pattern. Now this method is much easier, because if you know the tan inverse, just replace x with x squared, you get what you need. Doing with the table, finding derivatives, it will take a lot of time, a lot of work, and finding the pattern might not be as clear as it looks. Just to warn you here. Next example, we have x, and then we have cosine of something. So I guess we do the same thing as before. So f of x, x cosine of x squared over 2. Now for x, we'll wait. Now for the cosine, we have to write the... I will do the expansion form now. What is the cosine? Cosine was 1 minus something square over 2 factorial plus something power 4. Remember, it was the even powers. And that's it. Now in each one of these, we don't write x, we write x squared over 2, x squared over 2, x squared over 2, x squared over 2. Now we do a little bit of expansion here. So we get 1 minus, this will be x power 4 at the top over 2 squared times 2 factorial plus x power 8 over 2 4 times 4 factorial minus x12 over 2 6 times 6 factorial plus x16 over 2 8 factorial. And the last step gonna be take the x inside. So the final step will be x minus x5 over 2 factorial plus x9 over 2 4 factorial minus x13 over 2 6 factorial plus x17 over 2 8 factorial, and so on. And that's the expanded form. If you want, you can do the sigma notation form, and that I will leave it for you as an exercise to practice. It's very important to practice those questions. I assure you that those are very important for the coming lessons, not just for this question in particular, but when we do integration, derivative, finding limits, approximation, we will need to deal with cosine sine ex easily by changing the input. Oh, sine square of x. Now, this is a tricky one because if it's only sine, we know how to deal with it. Now, the problem is here we have sine square. So, we can have three options here. Let me write them down for you, just not to forget them. Option 1, to use the table. Not recommended. As usual, I don't recommend we think of the table. Table means finding derivative, after derivative, after derivative, and then finding a pattern. Maybe you are not good at finding the pattern. Maybe the pattern is so complicated you cannot really find it by having seen few terms. So I'm not recommending using the table. Second one is you find sine x and then you multiply it twice, which means you find the series for sine and you multiply it by the same series of sine, which again, because those are infinite series, the final answer will be difficult to spot a pattern. That would be difficult to spot a pattern. Not recommended. Option 3, think of another way, which is the same way we did it when we do integration of sine square of x. Do you remember when we do integration for sine square of x? We use a formula. Pause the video and remember the formula. Exactly, the formula is double angle formula. And what's the double angle formula? Here we go. Sine square of x. Double angle formula, it is 1 over 2, 1 minus cosine 2x. And from here, everything is easy because this is half, this is 1, this is minus. And here, you write the Maclaurin series of the cosine. But you replace every x by 2x. So I will leave it for you to practice it by yourself to finish it up. Thank you very much for watching this part. And if you have any question, please write it down for me in the comments. Welcome back, student, to part 4 of section 11.9. We are still finding the Maclaurin series for some famous function. Today, we will discuss the binomial series. And what is the binomial series? It's a series of this form. 1 plus x to a power of any number. We have seen something similar to this one from the geometric series. Do you remember this one? It is the same as 1 plus negative x to the negative 1. So they are of the same kind. So what we have seen before was just a special case of what we will see today. So today we will do it in general for any power, and it should be 1 plus x. And if it's not 1 plus x, we know how to make it 1 plus something. Now, what is the binomial series? It's in the sigma notation, starting from 0 to infinity, x to the n, and here something like this, which is k choose n. This is, we call it k choose n, or it's the combination between k and n. I will tell you how you find this number in a minute, but if we do the expanded form, this should be k0 plus k1 x plus k2 x squared plus k3 x3 and so on. So we can notice that the power of x is the same as the number down here, and this k is already fixed for all of them. Let me tell you how we find this in k, but before I tell you how do we find in k, I just write it down here, how you find it, kn, sorry. What is it equal to? Let us do some examples. I think through the examples we will know. Let me choose a number, maybe 3 with 2. How do you find if it's a 3 and 2? All what you need to do is, first of all, you need to put for me 2 factorial here. Now you have to start with 3, and then you subtract 1 out of 3, so it will be 3 times 2, and then you stop. Why do you stop? Because you need only 2 terms, because this is 2. Okay, now if this is 1, you will need only 1 term. If this is a 3, you will need 3 terms. You just subtract 1 and then 1, 2, 3, because we have 3 terms here. Now, in this case, we will need only 2 terms, so it will be 3 times 2, and this will be 6 over 2, which is just 3. Now, let me do another one. 9, choose 4. Same thing. Here we have 4 factorial, and here you need 4 terms, starting from 9 and go down. So 9 times 8 times 7 times 6. Whatever the number is, do it in your calculator, and that's the answer. Now let me do maybe 1 over 2, choose 5. Same thing, over 5 factorial, and here how many brackets you need to multiply? 5 brackets, starting from half, and then take 1 out of half, so it will be negative half, negative 3 over 2, and take minus 1, minus 1, minus 1, so minus 5 over 2, minus 7 over 2. Whatever the number is, that what you write it down. Simple and easy. And so in general, what we have here is the following. First of all, in the denominator, we have n factorial. In the top, we start with k, and then we just take 1. K minus 1, k minus 2, k minus 3, and so on. How many of them we have in the top? How many brackets? Should be the same as the number of n. So the last one will be n minus k plus 1. Because it is, sorry, k minus n plus 1. Because all of them is, look here, 0, 1, 2, 3 to n minus 1. Give me n terms. So that's exactly what we have. Let us go and see that in action. Oh, of course, if we have k with 0, by default, this is 1. Let's see this question. How do I know if it's a binomial series? It should be something to the power 1 over 4. It should be 1 plus negative x. And now, if we apply the power series, it should be 1 over 4, 0, plus 1 over 4, 1, and then something to the power of 1, plus 1 over 4, 2, and then something to the power of 2, plus 1 over 4, 3, something to the power of 3, and so on. How do we fill this bracket? We just write negative x, negative x, negative x. Now what we need to do is we need to find those numbers and subtract them there. So that's what we'll do next. So let me just do them here. I don't know. Maybe here is a good way. 1 over 4, 0. We said this is by default 1. 1 over 4, 1. This means I have 1 factorial, and here I have to multiply 1 over 4 only 1 time, so the answer will be 1 over 4. Now 1 over 4, 2, this means 2 factorial, and here I have to multiply two things. Starting with 1 over 4, and then taking 1 out of 1 over 4, which means 2 factorial. It means 1 over 4. If we take 1 out of 1 over 4, it is negative 3 over 4. If we multiply them, all in all, using your calculator, this is 3, 16 with 2, 32. And the last is 1 over 4, 3, which means we multiply three things. 1 over 4, negative 3 over 4, and then if we take 1, this is 7 over 4. So here 6, and then 64, and then this is 21. We take those numbers and we plug them here. So this is 1 plus or minus 1 over 4x, and then this one will be negative 3 over 2, 32 x squared, and this will be negative 21 over 6 times 64 x cubed, and so on. And that's what we need to do here in the binomial series. Very easy, very simple. You just need to find those using the calculator in the right way. I'm sure this is even easier. This is just 3 over 4, 0, plus 3 over 4, 1x, plus 3 over 4, 2x squared. Usually we do 4 or 5 terms. That's enough for us. Now the first one is 1. The second one, if we calculate it, this is a 3 over 4x. This one, if we calculate it, it's a 3 over 4 with negative 1 over 4. So it will be negative 3 over 8. 32, sorry. 32 x squared, and so on. And that's exactly how we find the binomial series. In the last part of this section, we will find integration, limits, numbers using series, which will be the last part of this course. Thank you for watching. Welcome back, student, to part 5 of section 11.10. Today we will discuss a very important topic, which will be kind of a revision of everything we did so far. It's about the applications of Maclaurin series and Taylor series. Now, the first thing we can see in number 10, if we are thinking of this integral x squared sine x squared, this is a little bit difficult integral to be found. I think we need to use integration by part in a certain way. So what we will do is we will use series to evaluate this integral. This is very difficult one. Even when integration by part, we will get stuck at some point. So there is no way, no method that we have seen so far can solve for me such an integral. And the only idea I have is to use the Maclaurin series. So I will write the series for the sine, and then I will do the integration. So let's see how this will go. First of all, x squared will wait here, and here I have to write the series for the sine. Now, you can choose between closed form or expanded form. It's up to you. My advice, and I will say it clearly now, do at home both. In every problem you solve in the book, practice the both ways. Solve it one time as expanded form, the other time as closed form. Please do it by yourself to get confident and to understand the difference between expanded form and closed form. In this example, I will just take a random choice. I will choose the expanded form. So I need to write the Maclaurin series for the sine. If you remember, the sine would be the one that has the odd power of x. So it will be something minus something power 3 over 3 factorial plus something power 5 over 5 factorial minus something power 7 over 7 factorial, and so on, dx. Now, what do I mean by something? It should be an x, but here my input is not x, it's x squared. So everything here must be x squared. So this would be x squared, x squared, x squared, x squared. Now, the next step is you do x squared. Now you expand this one. Let me just do it in a different color just to mention. This is x squared. This will be x power 6. Now 3 factorial is already 6. Plus x power 10 over 5 factorial is 120. Minus x power 14. 7 factorial is 5040. Or you can just keep them as factorial. Doesn't really matter here. Those are just numbers. Dx. Now the next step, take the x squared inside. So I think everything would be the same. We just have to multiply everything by x squared. So we get x4, x8 over 6, x12 over 120, x16 over 5040, and so on. The last step and the easiest one is to do the integration. And we all know how to do the integration. So let me just do it with a different color, just to mention that we are doing the integration up here. x4, it will be x power 5 over 5 minus x8, it will be x9 divided by 9 times 6, it will be 63 plus x13 over, we have to multiply 120 by 13, whatever this number is. Just do it and simplify it here. Minus x17 over 17 times 5040, and so on. At the end, remember we have the constant because we do the integration. That's how we do the integration using the Maclaurin series. Nothing more, nothing less. Everything should be the same. You can, of course, do the same question, but instead of having the expanded form, you just have to use the summation. And that's what we get. Now, the second question is very much similar to the previous one, but here he said he wants to find the approximation of this one up to 4 decimal places. So now this will get me back into approximation of series. So let me do this question now, and let's see how we can solve it. In this question, what I will do, I will use the sigma notation. You can use the expanded one, but we just used it before, so let's do something else. Now the sigma, it should be summation from 0 to infinity. Now remember the sign is alternating, so it is -1 to the n, and then it has odd power over odd power over odd factorial. Now what should I write here as x squared, because my question is with x squared. Now I think we can simplify everything. So this is integral from 0 to 1, summation from n0 to infinity, -1 to the n. And then here we have x to the power of 4n plus 2 divided by 2n plus 1 factorial dx. Now, of course, the summation and the integral can be exchanged. Everything with n can go outside. They have nothing to do with x. And then we have this integral, which is from 0 to 1, x 4n plus 2 dx. Now this integral can be found easily here. Now what is this integral? As the following. It is x 4n plus 3 over 4n plus 3 from 0 to 1. Now we have to substitute, I think, 1 and 0. If we substitute 0, there will be nothing, so we substitute just 1. And if we did 1, it will be negative 1 to the n over 2n plus 1 factorial 4n plus 3. Now this is the summation. Now if we want to find the answer within 4 decimal places, this means the error is 0.1234, so those are the 4 decimal places, and then maybe something like 1. So what we need to do, if you remember what we did in finding the error in the alternating series, we write the absolute value, the one without negative 1, less than or equal the error, and then we try to check which one will give me the error. So this will be 1 over 2n plus 1 plus 1 factorial 4n plus 1 plus 3 less than 0.00001. Now, as I said before, my advice to you, try to guess the number of n. So check n equal to 1. Do we get the answer less than 0.001? And then check n2, and then check n3, n4, and so on. So I will leave it for you as an exercise to practice. And please write for me in the comments what will be your n. And what will be the summation after you use this n. If n is 5, you need to substitute the first 5 terms. So you will substitute n equals 0, n equal 1, n equal 2, n equal 3, n equal 4, and then using your calculator, find for me the approximation. This is a very nice question because it has many ideas. We use Maclaurin series, we use integration, and we use the approximation of alternating series. Next type of applications for the Maclaurin series is to use it with the limit. Of course, with the limit, we have the powerful tool of L'Hopital, but in some cases, we will ask you to use the Taylor or Maclaurin series in order to find out the limits. And usually in the limit, we will use the expanded form. You can use the closed form, but the expanded form will be much easier using in the limit. So let me use the expanded form here. X goes to 0. I have x squared, I have x, I have a minus. And then here we have to write the expanded form for the len 1 plus x. Now, this is something I think we all remember it. It will start with an x. Okay. And then it will alternate x squared over 2. There is no factorial. It's similar to the e, but without factorial. And it's alternate. Maybe 5 terms is enough. Maybe even 4 terms enough. We just write 5 terms here. The next step, we just need to take the negative inside. So we get x, and then we have minus x plus x squared over 2 minus x3 over 3 plus x4 over 4 minus x5 over 5, and so on, over x squared. Now, x minus x get cancelled. Okay. And then we need to take x squared as common factor. So we take x squared as common factor. What will be left is half minus x over 3 plus x squared over 4 minus x3 over 5 and so on over x squared. Cancel, cancel. What we have is this one here. Half minus x over 3 plus x squared over 4 x3 over 5 and so on. The last step, substitute the 0 and the final answer is 1 over 2. Now please, can you check that we get the same answer if we use L'Hopital? That's the big question here. So what happened if we use L'Hopital? Do we get 1 over 2? Check that one and please write for me in the comments in this video. Another easy limit here. I think I'm leaving this one for you. It's all the same steps. Everything is the same. So please solve it using, solve this using the Maclaurin series. Okay. Solve this using the Maclaurin series. And write for me the answer in the comments. Okay. Now, look at this question here. In this question, I don't need to find the whole Maclaurin series. All what I need to find is the first 3 non-zero terms. So we need to find the first 3 non-zero terms. So what we will do is the following here. F of x equal. First, I will write the terms of the e minus x. Now, if you remember e minus x, it's a plus something square over 2 factorial plus something cube over 3 factorial. Maybe I will need the next term, but for now I'm not sure. Let me just write the first term. And then from the cosine, I think cosine is straightforward. It is 1 minus x squared over 2 factorial plus x4 over 4 factorial minus x6 over 6 factorial and so on. Now, what should I write here is negative x squared, negative x squared, negative x squared. And then we just multiply each one by each other. So the first with the first, first with the second, first with the third, and first with the fourth. Now, first with the first, this is 1. First with the second, x squared over 2 factorial, x4 over 4 factorial, x6 over 6 factorial. Next one will be negative x squared with everything. So let me just do it in a different color so that we don't mess things up. So it will be negative x squared, and then it will be plus x4 over 2 factorial, and then negative x6 over 4 factorial, and then plus x8 over 6 factorial. Now this one finished, this one is finished. Maybe we will need the next one, I'm not sure, but let's see how many terms will survive up here. So if we just write the final one, let me do it in a different color as well. The 1 is 1. Now the x squared, here we have half, so we have 3 over 2 x squared. X power 4, they will survive. So it would be x power 4, this is 2, this is 24. it will be 13 over 24. And those are the first three terms. Do I need the next one? Maybe. But he said find the first terms. So 1, 2, 3. 3 terms. And that's exactly what we have. So we have a couple of more questions. But for now, I'll stop this video. Thank you for watching. Please watch the next videos. Welcome back, student, to section 11.10 in Calculus 2. Before I start today's lesson here, in the third part where we discuss the Maclaurin series for the sine and the tan inverse, I did a mistake here, if you can see it, this one here. I wrote that the interval of convergence for the tan inverse is from negative infinity to infinity, and what I really need to say here is that this is wrong, and the correct one, or the correct exact answer, is the radius of convergence will be 1. And why I correct this one into 1? Because remember the way we get the tan inverse through this series, and we said if we do integration or differentiation, we keep the radius of convergence. Maybe the interval of convergence will be different, but the radius of convergence is still gonna be 1. So please correct this one in your note. And now, I'm sorry, we'll do this question here. Now, if you look at this question, this seems to be a little bit familiar. Why? First of all, it's alternating. It has even powers and over even factorial. Alternating, even power, even factorial, this seems to be something we have seen it before. Now, can you recall what is it? It is, yes, exactly. It is the kind of the cosine. But in order to know its cosine of what, we need to write it down into the same format for the cosine. The cosine looks something like this. Alternating, even power, even factorial. Now, alternating, this is alternating. Even factorial, this is even factorial. What do you think we should write here inside the bracket? Yes, exactly. It is pi over 6. Now compare the white and the yellow. They are the same. Just we're rewriting them in a different way. So the final answer would be cosine pi over 6. Which is square root of a 3 over 2. Okay. Whatever this number is. Okay, so that's how we find. Sometimes we give you the series as plug-in numbers inside it, and this is how we get the final answer. Now, the next question seems to be a little bit also familiar with us. First of all, you can see it has odd numbers and odd powers. I think we have seen something like this when we have odd numbers and odd powers. And that's exactly what we have seen was the tan inverse, which is summation odd over odd. Now, all what we need to know is what are the numbers. Now, what is the number that is having the power is 1 over 2. So just 1 over 2 here. So in short, this will be tan inverse of 1 over 2. Just try to mimic the series according to what we have. Next question is f of x equal x cubed cosine of x squared. Now what we need is to find the 11th derivative at 0. So here we have two options. We have to go to the old school, finding the first derivative, second derivative, third derivative, fourth derivative, until we reach the 11th derivative, and good luck with this. That's what we will not do today. Or we can find something with the series. Now, what do I mean by something in the series? Now, this is f of x. And the general formula, the general one, is this is n 0 over n factorial x power 11. So what actually wants to find is, sorry, not 11, it's n. Now, if we want to find f of 11, okay, here we must have the 11. We must find x power 11. So let me write it down for you. We need to find the coefficient of x11. That's what we are going to find. So we need to find the coefficient of x power 11. So we have to go back to the left hand side and try to find what will be the coefficient of 11. Now, the left hand side is easy. It's x cubed summation from n0 to infinity. It's alternating. It is even power over even factorial, and that is x squared, which is just x cubed summation -1 to the n x 4n over 2n factorial. -1 to the n. Now take the x power 3 inside. We get 4n plus 3 over 2n factorial. Now, how do we get the 11th power? So this will be, if we expand it, will be something, something, something. I want x11. What will be the number in front of x11? To get x11, which n will give me x11? I think 2. So we have to substitute 2. So it gets -1 square over 4 factorial x11. That is the power of 11. And now this is exactly equal the 11th derivative at 0 over 11 factorial. This means the 11 power of 0 equal 11 factorial over 4 factorial, whatever this number is. And that's how we solve it. So mostly comparing the power of x, that will lead us to exactly what we need. Thank you very much for watching.